dust eventually captured in a ring, perpetually orbiting the other galaxy. NGC 3314 is a pair of galaxies, a spiral aligned face-on over a larger tilted spiral. 140 million light-years from Earth, near Hydra, the nearer galaxy is silhouetted against a rare combination of light from the farther galaxy and the darkness of intergalactic space. This background highlights a pinwheel of bright blue stars that has recently formed near the center of the nearer galaxy. Looking at it edge-on, we see that the disk of this galaxy is twisted. 150 million light-years from Earth, the galaxy's warped dust clouds are silhouetted against its brilliant core. The shape tells us this galaxy collided with another, which it is now swallowing. Over millions of years, the disturbances will settle and the galaxy will resume its normal disk shape. This image of NGC 6782 is another study in ultraviolet. It reveals an unexpected bright ring of new hot stars surrounding the core of this galaxy 183 million light-years away. Emerging from the blue ring, two faint spiral arms are silhouetted against the gold clouds of older, fainter stars. In these outer arms, a few blue stars can be seen coming to life. When galaxies collide, so vast is the space within them that their individual stars almost never hit. Not so with the huge clouds of atomic and molecular gas and dust in NGC 6745. When it hit a smaller galaxy, their interstellar clouds sustained severe damage. The pressure on the clouds condensed them and triggered star formation, revealed by the hot blue stars along the galaxy's edge. Even more distant, at 270 million light-years from Earth, these 5 galaxies are called Stephan's Quintet. About 20 million years ago, at least 2 of them collided. The impact had gigantic consequences, ripping stars and gas from neighboring galaxies and tossing them into space. It also spawned over 100 star clusters and several dwarf galaxies, each holding millions of stars. This image is the clearest we've ever seen them. As Hubble looks out to the 400 million light-year mark, its images capture less detail but cover more area. These 4 galaxies, within 170,000 light-years of one another, are known as the Hickson Compact Group 87. The large edge-on spiral 87A and its bright elliptical neighbor 87B have active galactic nuclei. The bluish spiral galaxy 87C is probably undergoing a burst of star formation. These galaxies are so close, their mutual gravity is disrupting their structures and evolution. 500 million light-years away, Hubble saw this stunning result of a galactic collision. The Cartwheel galaxy had a smaller object, probably one of these 2 small galaxies, careen through its core. The astronomical ripple this caused is expanding at 200,000 miles per hour. In its wake, clusters of young stars are bursting into life in bright blue knots. Alongside, gargantuan loops and bubbles of gas are being blown into space by strings of supernovae. In 1995, Hubble looked at a portion of the sky just a fraction of the diameter of the full moon. It focused on the most distant horizon of the visible universe, over 10 billion light-years away. From the 342 captured frames, astronomers assembled this now famous mosaic, the Hubble Deep Field. This astounding image depicts hundreds of never-before-seen galaxies of all stripes, some born only about 1 billion years after the Big Bang, in the very infancy of the universe. This single image is one of the most valuable artifacts ever studied by scientists, and has already proven a rich source of data and discovery. Following the success of the Hubble Deep Field, astronomers in 1997 imaged 18 gigantic star clusters 11 billion light-years away. Closer than the farthest objects in the Hubble Deep Field, these clusters are still so far away that they emitted the light we see when galaxies were first forming in the universe. Over the eons, these clusters may have merged and become full galaxies. A remarkable complement to the first deep field, the Hubble Deep Field South, created in 1998, shows a sliver of sky in the constellation Tucana at the south celestial pole. A 12 billion light-year-long corridor loaded with thousands of never-before-seen galaxies, this image doubled the number of very distant galaxies astronomers can study. From such remarkable data, scientists will be able to educe volumes of knowledge and better understand the history of the universe. The massive cluster of galaxies, Abell 2218, lies in the constellation Draco, 2 billion light-years from Earth. Galaxies are so numerous here they exert a gravitational field that actually bends the light passing through it. Remarkably, the light is bent in such a way that it acts as a telescopic lens. This gravitational lensing effect magnifies and brightens light from objects beyond Abell, 5 to 10 times farther away. The uncanny phenomenon reveals galaxies from a time when the universe was just a quarter its present age. The lensing also distorts the light it magnifies, arcing the images of the ancient galaxies. Found in the Hubble Deep Field, the most distant supernova ever seen exploded 10 billion years ago. Analysis of the light from supernova 1997 FF supports the profound hypothesis of a mysterious dark energy that is accelerating the expansion of the universe. As the energy from the Big Bang dissipated, the expansion of the universe slowed. But after a time, galaxies inexplicably began to move apart at an ever-increasing velocity. Today, this remains one of the greatest mysteries of the universe.